Hi everyone, I am Arun JULKA. Today's topic is probability. Today we will be going to discuss some more complex problem of probability. Example first. There are two bags. Bag first, bag second. In bag first we have 3 red, 3 black and 4 white. In bag second we have 2 red, 3 black and 4 white. One ball transferred from bag first to second and two balls are drawn from bag second, which found to be 1 red and 1 black. Find the probability that the ball transfer from bag first to second be white. So first we are transferring ball and then we draw two balls which found to be 1 red and 1 black, and we want to find out the transfer ball is white. So this question go into in reverse. So when the question go into reverse, we say is a question of Bayes theorem. Let A1, A2, A3 denote transfer ball from bag first to second be red, black and white respectively. And after transfer, when we draw two balls from bag second, B denote 1 red and 1 black ball. What's the probability of A1? A1 denote red ball. The red ball from the first bag is 3 by 10 because we have 3 ball out of 10. Then what's the probability of A2? A2 is a black ball. We have 3 black ball out of 10. The probability of A2 is 3 by 10. Then the probability of A3. A3 is not white ball. We have 4 white ball out of 10 in the first bag. So probability of A3 is 4 by 10. Probability of B by A1 means probability of 1 red and 1 black from second bag when we transfer 1 red ball from first to second. When we transfer red ball from first to second, then we have 3 red, 3 black and 4 white. And now we want to find out 1 red and 1 black. So it is 3C1 upon 10 because total number of balls are 10. Then B by A2. B by A2 is 1 red, 1 black from second bag when we transfer a black ball. So now we have 2 red, 4 black and 4 white. Probability of 1 red and 1 black is 2C1 into 4C1 upon 10C2. Then probability of B by A3. B by A3 is 1 red and 1 black from second bag when we transfer a white ball. Now we have 5 white, 2 red and 3 black. Probability of 1 red and 1 black is 2C1 into 3C1 upon 10C2. Here we use combination because the question of without replacement. So after calculation we will get the probability of B by A1 18 by 90, probability of B by A2 16 by 90, probability of B by A3 is 12 by 90. Now we want to find out probability of white ball transfer from bag first to second when we already drawn 1 red and 1 black. So we want to find out probability of A3 by B, which equals to probability of A3 into B by A3 the whole divided by probability of A1 into B by A1 plus probability of A2 into B by A2 plus probability of A3 into probability of B by A3, and after calculation we get the answer 8 by 25. Next example. Find the probability 3 persons have birthday on same day. What's the required probability? Probability the first person have a birthday is 360 by 365. Now the second have birthday on the same day. So he have only one option, 1 out of 365. Third have birthday on the same day. So you have again one option, 1 out of 365. And after calculation we get the answer 1 upon 365 whole square. Next example. Find the probability out of 3 persons, at least 2 have birthday on same day. At least 2 have birthday on same day means either 2 have birthday on same day or 3 have birthday on the same day. Or we can say 1 minus none have birthday on same day. This implies all have birthday on different day. 1 minus. Probability of first person have birthday is 365 by 365. The probability of the next person have birthday on a different day. So you have 364 option out of 365. And the third person have birthday on a different day, he have 363 option out of 365. Required probability is 1 minus 364 multiplied by 363 whole divided by 365 whole square. Next example. A and B toss a coin alternately until head appears and wins the game. Find the probability of the respective winning. Here probability of winning denoted by P, which is 1 by 2, and the probability of failure denoted by Q, which is also 1 by 2. Here A start the game. So we have two people A and B and they toss alternately. So chances of A's winning either in first chance or third or fifth or so on. So probability of A is P, or third means 2 times failure then success, fifth means 4 times failure then success, and so on. In GP we know the formula of sum of infinite. It is A upon 1 minus R. Here A is P and the R is Q square. So P divided by 1 minus Q square, and after simplification we'll get the answer 2 by 3. Now the probability of B is equals to 1 minus probability of A. So the probability of B is 1 by 3. Because A tossed first time, so the chances of A's are more than B. The probability of A is 2 by 3 and the probability of B is 1 by 3. In the next example, A, B and C throw a dice alternately until 6 appears and wins the game. Find the probability of the respective winning. Now, instead of 2, we have 3 people. The probability of winning is 1 by 6 and the failure is 5 by 6 because the probability of 6 is 1 by 6 and the probability of non-6 is 5 by 6. A start the game. So, chance of A is winning. First chance or fourth chance or seventh chance and so on. So, probability of A is first chance means P. Fourth means 3 failure then success. Seventh means 6 failure then success and so on. It's a GP. The formula of sum of infinite terms of a GP is A upon 1 minus R. Here A is P and the R is Q cube. So it is P divided by 1 minus Q cube, and after simplification we get the answer 36 by 91. Now the chances of B is winning second or fifth or eighth and so on. So probability B is second means first failure then success, fifth means 4 failures then success, eighth means 7 failures then success. Is again forming GP and the formula is A upon 1 minus R, and after simplification we'll get the answer 30 by 91. Now what's the probability of C? It is 1 minus probability of A minus probability of B. After simplification we get the answer 25 by 91. So the probability of A is 36 by 91, probability of B is 30 by 91 and the probability of C is 25 by 91. Next example, a bag contains balls number 1 to 30. 5 balls are drawn at random and arranged in ascending order. Find the probability the third number is 20. There nothing is given about replacement, so we'll take is a question of without replacement. 5 balls are drawn, so total events are 30C5. Here we choose 5 balls. Let x1, x2, x3, x4, x5 are the numbers on the ball drawn because they are in ascending order. So x1 less than x2, less than x3, less than x4 and less than x5. We have to find the probability the third number is 20. Third number 20 means x3 is 20. So x1 and x2 out of 1 to 19 and x1 and x5 out of 21 to 30. So number of favorable events when x3 is 20. So first we choose 2 number out of 19, which is x1, x2, and we choose x3, which is only one number, 1C1. Then we choose x4 and x5 out of 21 to 30, which are 10 numbers, so 10C2. So the required probability is 19C2 into 1C1 into 10C2 divided by 30C5. Next example. First a red die and second a black die are rolled. Find the probability that the number shown on the black die will be more than twice the number shown by the red die. We have total events because 2 dice are thrown, so total events are 6 to the power 2, 36. And this is a sample space. A red die and then a black die. Now we want to find the number of favorable events. Number shown by the black die will be more than twice the number shown by the red die. Now red die show 1, so number on the black die is more than twice, which is 1 3, 1 4, 1 5 and 1 6. In the case of 2, now we want number shown on the black die will be more than twice the number shown on the red die. In the case of 2, it is 2 5 and 2 6 and no other case. So total number of cases are 6. So the required probability is 6 out of 36, which is 1 by 6. Last example. If A and B are 2 events such that probability of not A and not B equal to 1 by 6 and probability of A and B equal to 1 by 4 and probability of not A is given 1 by 4, prove that A and B are not equal likely events but independent. Probability of A is 1 minus probability of not A, which equals to 1 minus 1 by 4 is 3 by 4. And probability of A union B is 1 minus probability of A union B not, which equals to probability of not A and probability of not B. And after simplification, we get answer 5 by 6. We know that probability of A union B is probability of A plus probability of B minus probability of A intersection B. Union is given 5 by 6, A is 3 by 4, B is not known, and the A intersection B is 1 by 4. So probability of B after simplification is 1 by 3. Now probability of A is not equals to probability of B. So A and B are not equally likely events because the probability of both are not same. And again, if we calculate probability of A into probability of B, which equals to 3 by 4 multiplied by 1 by 3 equals to 1 by 4, and is exactly equals to probability of A intersection B. So A and B are independent events, or we can say A and B are independent